Good evening, everyone. Let's start the session. Today we will deal about different file formats. Uh, like you have seen PDB file format already, and we will be discussing more file formats so that whenever required we can understand what their need and where they are used. In the last session, we have already extracted different structures from a file manually using text format, and also we understood how what we are going to do during the docking. Also, we have installed Autodock Vina, and most of us have installed 1.2.3 version, and a few of people were not able to install 1.2.3 on their system, so I instructed them to install 1.2.1, which is an older version. So till now we have already used PDB file, and what what do we get inside a structure file we download from different databases? Can anyone tell me? Means, what do you understand by a structure? Means, what are the attributes of a structure? If I am talking about a protein, what are the attributes you can think of? You can get from a file or a name.
Sir, it has ligand. It has atoms, proteins, 3D, 2D structure of proteins, ligand, residues. These are different. These are the things which has attached in a PDF file of any protein structure. I think like these are the attributes or these are the things.
Okay, so basically, you are talking about means different components of us in a structure.
Yes, sir.
But
Yes, sir.
okay, so in a structure there are also like physical attributes could be there, like uh, size of a structure, different dimensions, like what is its height, width, or its occupancies, and sometimes we need to get density of a structure, like how dense it is, and and some other attributes could be like what's its composition. Composition means uh, different atoms. So these are basic things we get from a structure file, or different information from a file. And if we are talking about a structure representation, like you might have already gone through a research paper where they are talking about different structures. Like if they are performing some docking experiment, they will be mentioning about protein structure and ligand. So for PDB file format, sorry, for PDB format, they might be mentioning some protein ID, and on PDB database there is three-dimensional structure. So basically, if we talk about representation, like if I want to communicate with you about a structure of a molecule, biomolecule like DNA, RNA, or any protein, then I can basically tell you the name of the structure. Like if I want to talk about P53 or hemoglobin, so if I tell you the name, you can understand that what it should be look like and what's the composition of the structure. Second, uh, second thing is that if I can communicate to you using some composition like chemical formula you have already studied in chemistry classes. But what's the problem with the chemical formula? That it will tell you simple two-dimensional structure or one-dimensional structure. One-dimensional means composition of atoms. So what's the composition atom? It can be get we can understand through chemical formula, but it won't tell how it is how different atoms are arranged, and that information can be obtained through bond length, which is already experimentally established, and bond bending, bond angles. So all those things can be deciphered basic things from can be deciphered from chemical formula, but that's not quite accurate. And next is dimensional structure, which is basically derived from chemical formula or one dimensional structure, but more complex is three-dimensional structure, like what's the arrangement of different atoms in a structure. For example, if we talk about alpha helix, there we have seen that there is peculiar arrangement of atoms and in a residue, and later on these residues turn or conform to give a specific helical structure or beta sheet. So that arrangement we can get from three-dimensional structure. So like this means there are different structure representation, and those structure representation have different formats. Before going to different file formats, I want to tell you about what is the meaning of a format. So format means a kind of language, like in silico or through computation or for textual representation, we have some rules or some syntax or some format. So those formats are bind to file formats, means they will follow the same pattern, same approach to represent a structure. Like earlier we have observed that in pdb format there are multiple columns, like first space uh, first column separated with space has record name, like you have seen atom, hit atom, or remarks, something like that. So that is a specific format. We have already gone through pdb format, and there are multiple other formats which I will be discussing and telling you the name of PDB, MOL2, SDF. These are different file formats used by different file formats, different softwares for different purposes. Like in chemistry, there will be people who will be presenting their structure in different way, and biologists want their structure in different way. Means for different purposes, structures are different, and likewise, file format also differs. Basically, we have seen PDB file format. I have already mentioned about different records and different records and their values. I will tell now. I will share where you can get more information about this. So to get more information, we can simply Google about it. because I can't cover all the structures over here, so it will be better if you can find more about these structures yourself. So PDB file format, column information. So here is one website research group who have mentioned all the structure information about PDB file format, so we can get it from here. Like earlier I told you about different columns. Here they have mentioned that column 1 to 6, but here by column 1 to 6 means first character is first column, second character is second column, third character is third column. So there are total more than 70 and more than 70 and maximum 80 characters or 80 columns. So if I select a single row in a PDB file, there will be total 80 characters or 80 columns. So like that they are mentioning that 1 to 6 column is a record name. So first, second, third, fourth, fifth, sixth. So till here you will get a record name. So this remark word is has 6 characters or 6 columns and it is a record name. So what a software does is it will take first 6 character in a line or first 6 columns in a line and take it as a record name, and later whatever values comes they will consider it as a value of that record. So like this you have seen atom has only 4 characters but and 2 spaces are there for its record name, and similarly het atom and other records will be there. Next is your 7 to 15 7 to 15 are okay. So there are different means for different records these remaining column have different value format. So I will directly move to atom record because that is more important for now, because other details are not much necessary uh, for today's class, and I will share all these things with you so that you can also observe it yourself. So I will that yeah. So this is I am just directly switching to atom record type. Here in atom record type 1 to 6 columns are record name. For every other record 1 to 6 columns are record name, and next 7 to 11 means 7th, 8th, 9th, 10th and 11th. So till here it is a atom serial number, means if a structure is there, there will be atoms and each atom is given a number. So that record comes here, and next 13 to 16 means two spaces are given, two columns are left, and after two columns from 13, 14, 15, 16 there will be some record which is named as atom name. So here it is given atom name, and this atom name has since each and every atom is in a structure could be bound to some carbon or some carrier molecule. So due to that one, to identify to differentiate between two similar atoms, like here if we see these these records, I am ignoring A and ISO record. This record is regarding some isotropic condition. So if I see this atom record and this atom record, these both are in same glutamic acid residue, and on same chain, and residue number 303, but their atoms are same. So to differentiate their binding with binding in the residue, they have further differentiated using E1 and E2. So this relates with their identification. So first character is the atomic element, and later on it is differentiated using given some ID. Next we see that there is on record on 17, means after this one column is given to alternate location indicator. Alternate location indicator means one atom, if for when a structure is determined, single atom could be found on multiple places, like for example protein p53, there could be some atom at number 8, and at an earth atom in that structure could have been identified to have multiple positions. So like you have already gone through isomers, or so those varying position can be denoted using this position. Here it is not given here. uh, if I found one example, I will share it with you or through question answer. And next is your residue name, and 18, 19, 20, 20th. So three characters represent residue name, and later on 22nd character is chain identifier, and later uh, residue sequence number, and like this these records are present. And similarly x coordinate, y coordinate, and z coordinates are there, and later on occupancy means how often it is a structure is present, and other information. And recently for 79 to 80th position means here we are missing something, and here some of the pdb record provide charges. This is means recent change, and earlier in many files you won't see this charge thing. And for that, the charge to get the charge in a file, there is another file format pdbqt, which is same as pdb file format, but since it includes charge information specifically, it is called pdbqt file format. Like I have already shared you one pdbqt file. So here we will get one pdbqt file format. To open this file, I will directly drag and drop here so that we can see it. So we were missing this file, this column in pdb file, and this is the charge. So my negative value means negative charge, and no negative sign or plus sign means it is positively charged. Last column takes some uh, atomic atom name or element name present in that residue or structure. So these two file formats are similar. Next is your mol2 file format. So I have not downloaded mol2 file format. I guess uh, while uh, while searching different drugs or different structures, we might have gone through other file format. I will go to pubchem, where I will try to search for some drug aspirin. That's random search. And it will provide me different file formats from this download section. And currently it has sdf file format, but not mol2 file format. So Let me check in drug bank. Okay, so here it is mol format, not mol to file format. Actually, mol format and mol to file formats are different, and mol format is quite related to SDF file format. So I will cover SDF and mol file format in one go. I am opening mol file format. I am not explained mol to file format yet. So here we are seeing that this is a mol file format. Earlier we have seen in PDB file format there were coordinates about the location of the atom and atom name. So in there in PDB format there the arrangement or column information was different, and there was a record name before every line, but here there is no such thing. Here we can see that this is kind of one block here and then another block here. So only this information forms some structure. I will open it in Chimera X so that we can visualize it right now. So this is mol file format, and to get more information about this mol file format we can Google it. I am going to Wikipedia page. Here there are record types like there will be a title line like we are seeing here. This first line is a title line, means what is the name of this chemical or chemical structure. So and there is some stamping, and currently there is no second line here, so it is missing some that information, means that is not required. And comment line means if some software is exporting that file format, there could be some specific comment like it has included or excluded something, it will mention that. And next one is a count of lines, means how many lines are there, like in this record there are around 40 atoms or something, so it is mentioning all those things here. You can grab more information through online. And next, atom block and bond block. So atom blocks are like how many atoms are there, and they will be having they will be having their xyz coordinates, atom um, or and atom name. And next one is atomic bond block, means for every atom there will be some bonding, means they will be connected with some other atom, so that bonding information will be present here. And next is properties block. That property block means if there could be charges or some different spatial position like we have discussed in PDB file format. And last one is one end line, so that it tells that this file is ending here. And for similarly in PDF file you will be seeing record, termination record, that will terminate one chain. uh, so this ter record indicates that list of atom or hetatom of records has ended here, means if there are multiple two chains, you will get at least one termination record, means for first chain it will terminate somewhere, and for second chain it will terminate somewhere. So uh, beyond TR record you will get different chains or separated structures. So basically a mol file and PDB file may have multiple structures. And similar to this is SDF file format. Most of the drug information you will be getting from this file format. It is also similar like that of our mol file format, and more information is stored here. the information about the molecule has ended here with end record, which we have seen in mol file format, and later on more information is present here, like it is providing us some database id, database name, or file name, even different file format structure or other identifiers are also present. So like this, different file formats vary and they are used in different packages. You won't need to go through these records, but you should have understanding of these file formats. I will take one example of smiles. Better I explore it here. So I already told you that we can represent a molecule in one dimensional, means atom composition like we do in chemical formula, or we can also represent a molecule in two dimensional or three dimensional. So with simple text thing, like a chemical formula, or some, you are seeing a chemical formula wrapped in square brackets and parentheses. So these type of records also represent a chemical structure, and it is a two-dimensional chemical structure. So and it is known as SMILES file format. Also there is another file format used by chemists, that is Inchi identifier. So they use some different syntax or different structure information, and that is represented like this. So in your research paper you will be seeing that uh, scholars are mentioning smiles file format or Inchi file format. So that is very compact. So and for if we talk about HDF file format, that is going to take around 40 to 80 total lines, 80 lines. So and but this will take only means few correct one line, and it is very compact. So if you want to compact communicate in SMS or simple email, it will be easily communicated. So these were different file formats. For now I will keep exploring about these file formats over the time, because we will be needing to draw molecules or convert molecules, and these different file formats will be helpful to us. uh, in different file formats we have seen that this kind of structure. And when you were exploring protein, that was three dimensional till now, and here we see that this is a two dimensional, means it has it has it has x axis and y axis, but it is not raised. You are seeing the height, means this uh, height of the structure, means bonds. It is just a representation to make it clearly visual to you, but this is not 3D structure. If we see from the third dimension, align it on z axis, then we will see it as a flat. So this is two dimensional structure, and earlier we have opened some protein structure. We can rotate in z axis, and we can have visualization in different from different axes or different angles. So this is two dimensional structure, and the protein you have already observed is three dimensional structure. So anyone has any question from till now?
No, sir.
Okay. So tomorrow I will be covering uh, conversion conversion and comparison of different file formats. Like we have already extracted residues. Like if we take serine residue, you have done assignment about serine residue. There you extracted serine, and if I am trying to extract all the serine residues from a protein, and I want to check if the conformation or bond angles in a serine residue are same or not. That For that we need to compare different structures. We will be doing those things tomorrow, and for that purpose I will be telling you how to do that. uh, So there will be a complete assignment from today's and tomorrow's session. You have already run Autodoc Vina, but I am expecting that everyone is able to run Autodoc Vina. At least they should be able to get this screen. Let me open it. Basically, Autodoc Vina is command line tool. Just if I type Vina only, I will get. I'm not getting Vina. Okay. I have installed Vina here. I've just downloaded Vina here, so I will copy it. I will change the directory using cd command, and there I will type Vina. So I'm expecting you all to just get this much off screen, and tomorrow I will be sharing how you can install OpenWebel. So for that you will be getting some output like this. There is GUI tool as well. I will also help you explore that too. So these two will be assignment from today and tomorrow's session. Next I will tell you about comparison. So is there any question from till now?
Hello, sir.
Yes.
Sir, could you please once again explain like how to extract the serine? Like this was in last assignment from the structure.
Sure. So I am taking one protein structure. I will change it. So display. So here will be some serine residue. Let me check it once if the serine residue is present. So for that I can directly go to ACR. So there are serine residue, and there are 18 serine residues in here. There can be multiple approaches, and one basic approach is using text file. I will open it with Notepad. Uh, interrupt me if you miss something. I will use Control F to find serine residue. I will check for atom record. Okay, so here I am seeing serine residue here, and since 3 to 8 residue is serine, and it has atom from 216 to 221. So all this information is regarding serine. I will copy it and open a new text file and save it. So all these atoms belong to serine residue. I will save it as this one, serine.pdb. I will directly drag and drop it here. Let me close other structure. So this is serine residue.
Okay, sir. And sir, like you selected the atoms from 216 to 221. So, like how it is possible that the one single amino acid is present from the 216 to 211 at the same position?
Okay, sure. I'll let me explain it again. You understood? I told you about different file formats of molecular structure.
Yes, sir.
Okay, so I am taking a random example here. It has anisotropic residue record might be confusing, so I am taking another example. Okay, so you are seeing this whole file, right? Fine.
Yes,
And
sir.
next I mentioned that first to 6 column tell you about record name. These, so all these first words are record names, and this is atomic atom serial number, and then you are getting atom names, and then residue name of 3 characters, then chain name means in which proteins chain it is present, and then residue number. This is residue serial number. So residue serial number and residue. So I'm focus on these two columns, first this column and this column, and the column in middle between these two columns is chain id. So if I see this, uh, check the highlighted lines, I am seeing that isoleucine or ILE residue is given here. So it is starting from ILE and ending here. So this is one residue, and its serial number is 317 in the protein in L chain. So this is isoleucine. Similarly, if I check this residue sequence, so this leucine is starting from here and ending here, and its residue number is 318. And since second column is atomic serial number, so 3786 to 3793 atoms are part of leucine residue. So I guess it is clear now.
Okay, okay.
Okay.
Now I understood.
Okay. And similarly, if I try to find other isoleucine residue, I can just search it. Okay, so there is I guess only one isoleucine residue. I will check other residue leucine. So another leucine residue is starting from here. So it is starting from here to here. Let me simplify one. I am copying this leucine one residue as one file. Basically, what I can do is I am copying this whole record here from here to here. So both the leucine residues are here. I will delete other records. So I will take a new file, Control V. I will delete other records, then less leucine. So the leucine at bottom or 321 is here. I will save it as reslu1.pdb. So one record is saved here. Now I will take one new file and again paste the same thing and delete other than 318. So I will delete including 321 as well. So 318 and 321 leucine are present here. I have saved. I am saving it again. Residue leucine2.pdb. So I have saved these two files. Now I go here and open Chimera. I will close other residues, other structures by using close command and drag and drop it here. Here I am seeing that there is two models. First is first file name is leucine1 and second is leucine2. So I can also use view all option to visualize all the residues. So since this one is 321 and this one is 318, so these are quite close enough, so we can see them side by side. So these two leucine residues are extracted, and I have saved it, I have visualized it as well. Do you have any other query or question?
Okay, sir, I don't know whether we are going to learn this in future or not, but just I'm asking. Suppose like that we what we normally do inside directed mutagenesis is we replace the particular amino acid with the other amino acid. So suppose from this file, from this like you just showed that key we can extract serine. So suppose in place of serine, I have to put some other amino acid. In that case, how would I be able to put that? Because I don't have that specific information about the aniso and atom number. So how can I do that?
Let me tell you. Actually, these records which you are already seeing in PDB format are experimentally derived. So, and when you are going to perform to get mutated structure, you already have amino acid sequence, right? Amino acid to amino acid n. So that sequence is going to take some conformation, and that structure is means wild type structure is or experimentally derived structure is stored in PDB. So if you want to perform mutagenesis here, like you know that one amino acid at position 231 has changed from means earlier it was leucine, then it changed to some glutamine or some other change has happened. So you already have this structure and you want to replace this amino acid with new amino acid, so there will be multiple changes. Like first what you will have to do, first there will be change in one dimensional structure, means sequence will change. Then in three-dimensional structure, according to that sequence change, the conformation of the protein will change.
Conformation.
Yes,
Right.
conformation of the protein will change. So that conformation is dependent on thermodynamics of the protein and its environment. So you might have heard about molecular modeling. Molecular modeling, like also heard about AlphaFold.
Yes, sir.
Okay, so AlphaFold, Rosetta, and other many software which perform molecular modeling. So using that thing, you can perform, you can get the new structure, because after change in single amino acid, there is change in structure information, means structure coordinates will be of the atoms or residues will be changing. So in text file, if you are just changing a single amino acid using by replacing and modifying, it is not going to give you a right structure. I hope this point is clear to you. So for that,
Yes, sir.
what
Yes.
we do, we also change the thermodynamic parameters accordingly by exposing it to AlphaFold AlphaFold like modeling softwares or modeling packages. Or what we do, we do a energy minimization using molecular dynamics packages. So I will be also sharing how you can perform molecular dynamics using GROMACS. So that will be covered in later session. Also I will be covering AlphaFold 2, means for basic actions, so that you can get structures which are not already present in PDB file. There are around more than 80,000 proteins in a human body, and around only 50,000 structures are present in PDB. So there is a large gap, and recently AlphaFold has also derived many structures, but mutated structures may not be present. So for that we need to perform molecular modeling, or we need to do it through energy minimization or molecular dynamics. Any other question from
Okay,
anyone?
sir. Thank you, sir.
Welcome. Okay, so this assignment,
Hello, sir.
yes.
Sir, how will we interpret the last class data like we docked, ligand, and the protein? Can you tell us?
Can you repeat your question?
Using, sir, we used Autodoc Vina in the last class.
Yes.
So I was asking how will we interpret the result that we got from that?
Okay, so in the last classes, I was trying to make everyone install Autorock Venus, and I didn't ask anyone to perform the docking. So basically, what in the next session, before starting docking, we need to understand file formats, and also we need to understand how docking works, and then after the docking, we will be uh, doing analysis part. And in analysis we basically see how ligand is interacting with protein, so that part will be like bit later. So basically I was expecting everyone is able to download Autodoc Vina, because till now many people are not able to install and run Autodoc Vina, which is a very simple software. I will be covering it over this few next sessions.
Okay, sir.
Okay, any other question from anyone else? Okay, I have one question. What is difference between a file format and ID? Like you have seen PDB ID, some 3x N8 and .pdb. So what's the difference between a file format and an ID? Unrelated. These two terms are quite unrelated, but could be confusing.
A protein of having a particular ID can have different file formats.
Okay, so I already told you that a file format has specific syntax or specific set of rules to represent a structure. That is a file format. Like if we talk about a text file, or we talk about a .md file or docx file format, so all those file formats are different and used by different software or packages. And id is identifier. So if we go to protein data bank, they have different id format like this, 4 characters or 6 characters. And if we go to pubchem, they have different id set. And if you have visited drug bank, they have some db00 something id format. So id is specific to database, and if a database base is universal, that id can be reused or mentioned in a research paper. So uh, I guess file format and id difference is clear to you. And in the next session we will be dealing with structure comparison. Means if you get download two proteins or you have two proteins, how you can compare those structures. I will start with very basic, like first I will help you compare two residues, so that you have a basic understand what actually a comparison is. And next I will like we have done installation of Autodoc Vina, I will let you install OpenBabel. If any of you is able to install OpenBabel in advance, it's good. I will share a link of OpenBabel in advance so that you can try it yourself. And also I will share other resources like file, where you can get more information about file formats. Let if you anyone has any question, please put it in Telegram. I will try to answer those, and tomorrow these two topics will be covered. Okay, thank you.
Thank you, sir.
Should I terminate the meeting? Any other question?
Hello,
Yes.
sir. How to visualize ligand? See, if we visualize ligand, then they will represent in different color of ligand.
Yes. Okay, I
So,
have. Yes.
yes, sir.
You are telling you are asking that how we can visualize a ligand, right?
Yes, sir.
Okay, so first first thing is that a ligand, you are able to select the ligand using using Lig residue or unknown residue, or just by identifying through selection command. I will take one example, 3 1. So there should be some ligand, select structure ligand. So ligand is selected using Lig command. So to visualize it, what we are doing, we are just differentiating its representation from other structures. Like if we just hide other structures, so to hide other structures we can use uh, selection invert. I have inverted. Invert means earlier I was able to select only ligand, and if I invert the selection, other than ligand will be selected. So here I have inverted it, and I want to hide it. So let's see, everything is hidden. My mistake.
Sir, actually, this log box is not visible in the older version of Chimera. That's why I think Vasu and me, like who are using this older version, are facing problem.
Okay, yes, I am I have installed older version as well, and uh, I will be also using uh, older version as well to demonstrate, because basic functionalities and names are same in every version, just that GUI is differing, and they are providing more easy easy tools. So I will be using those older version as well
Like,
from next
yes,
time.
sir. So newer version is like very user friendly.
Yes. So here what I am changing the representation to stick, hide it, hide hide. So everything else is hidden. I am able to see ligand clearly. Now if I and protein is still selected, so I can change its representation here and go back and do the inversion, and now ligand is selected. I can change its format by to show it in different representation. Like currently I am able to see the surface of the ligand, like it is showing van der Waals surface, means charges over the that atom. And since it is hidden within the protein, to visualize it more clearly, I can use this uh, slide side view. It will be present in most of the packages, or there will be some shortcut to use this thing. I will click this part, and using these rows I can hide other atoms and clearly visualize the ligand. So like this, can we can use, or we can just use view selected. So like using these features we can clearly visualize ligand. I will be explaining these means how you can create a quite appealing structure like you have seen in your research papers, but that will be like taking 4 to 5 steps to visualize and represent. So I will be gradually uh, help you at doing all those things. So Vasu, you were asking about ligand visualization.
Yes, sir.
I guess
Okay, sir.
you can first select it, and you can first select it and change its representation to make it distinct from protein. So for now that should help you distinguish ligand from protein or other structures.
Okay, sir. But when I was doing that,
Yes.
it's only highlight that ligand part.
Yes.
But after highlighting, like how can I find the which atoms is present? Like you are uh, representing in different spherical form.
Yes. So for that presentation, I can go to action. Like this, I am going to surface. I can use show hide option, and or you I can change mesh or any other representation you can use. I will be explaining these different representations while analysis and document representation of docking results. So we can use these things, means using action command, and I can use that. Actually these different structures or different representation are specific to different uh, formats. Like if we talk about helix, then helical structure is present in DNA, RNA and protein, not carbohydrate or not carbohydrate or lipids. So if we try to visualize cartoon or helix or ribbon structure, then we won't be able to visualize it in um, lipid or carbohydrate. So like that, these different structure are specific and give different results according to type of molecule. So I can use surface or atom bond type of representation for these atoms, these ligands and other structures.
Okay, sir. Okay, sir. I will try.
Okay. I guess you are able to do the selection thing at least.
Okay, sir. Sure, sir.
From action or something. So, and for that I have to revert older representation, hide. So like that we need to try learn different combinations to clearly visualize particular structure. I will hide, restrict other things using this part, so that I can clearly visualize a ligand and a nearby atom. Actually, over the time you will be learning that if we have a ligand, I I want to select visualize only this part, means this area. Then we have different settings and different, and we can also name this selection part only. So for that we need to use some zone selection and other things. So I will be explaining all those things over the time, and let's keep it simple for now. Any other question from anyone else? Okay, I will terminate the session, and I will request to put your questions in Telegram group so that we can cover it tomorrow, and I will be able to find some good examples, so that you can understand your queries well. Okay, thank you everyone. I'm terminating.
Thank you, sir.
Welcome.